So in the previous two videos, I gave you a little background about the instrument and about the process of processing samples with blood alcohol content. We use this thing called a headspace gas chromatograph with a flame ionization detector, or HSGCFID. Now in this video, what I want to do is give you a rundown or a brief overview of what you're going to be expected to do in the procedure. Number one, you will not do this by yourself. Okay, so if you look at, and this is kind of different than all the other labs that we've done in the ChemTech program before, right? So if you look up here at the very top, it says your team will need to prepare. So your team could consist of maybe 2 or 3 people, and you're going to be working together to make a set of standards and to process a set of samples. So you will be sharing data, you will be sharing in the sample prep, you'll be sharing in the data analysis, but you will be turning in your own data sheet with your own questions answered, all right? So I don't want one sheet only to represent all 3 people of the group. I want you to work together to process the samples in the lab, but after that, then it's over. I want you to do your own data analysis with the instrument. I want you to plot your own calibration curves. I want you to plot and solve for your own concentrations. I want you to answer on the questions on your own. You're only helping each other when it comes to the sample preparation and the standard preparation, and that is it. All right, so it looks like this lab procedure wants me to first create something that we're going to call a stock calibration solution, or SCS. All right, so SCS is going to be a standard that I'm going to make other standards with. Okay, that's why we call it the stock calibration solution. And it tells me how to do this, right? So 1 gram of 100 or per 100 mils. And that equates to a 1% solution. Notice that 0.08% is really low, right? So we're going to have to make standards that are that low in alcohol. And the only way that we can do that is if we start off with a really low concentration in the beginning. So it tells me weigh out 1 gram of ethanol and put it into a 100 ml volumetric flask. Use DI as the solvent. Mix it, shake it, and then label it. That's all I got to do. So in your group, have one person to make the stock calibration solution, and you're already kind of a quarter of the way there. Something else that I need to tell you about is that ethanol in our laboratory is 95% pure. It's not 100% pure. So this says weigh out 1 gram of ethanol. And that's why that's underlined. Because if we really wanted to be particular and do our job the right way, we would correct for this. So if I'm to weigh out 1 gram, but if I'm assuming that is 100% ethanol, and it is not, well, how many grams do I need to weigh out if it's only 95% pure? So this is how I would do that calculation, 1 over 0.95. That's it. This is my target, and this is the concentration of the standard that they're going to give me. So I take 1 divided by 0.95, and I get something a little bit more than 1 gram, and that's good, because by the time I weigh out that little bit more than 1 gram, because it's only 95%, I will get 1 gram exactly of the ethanol. So do that calculation. That is what you would need to weigh out and transfer into a volumetric flask. Once that is accomplished, you would then use your group and use that standard to make a series of working standards. And if you notice over here to the left, we're going to go low ranges of 0.02. We can go lower if we want, but I'm not going to get you to. And we can go to 0.20. That's way over the legal limit, but quite honestly, in a normal forensics lab, we'll go even higher. We would normally go to like a 0.5, almost to the brink of a person is dead when they drink so much that they go into a coma, all right? That way we can process these samples and not worry about rerunning anything or remaking a calibration curve because the sample does not fit within the range, in case we get a super drunk that gets submitted to the lab. So 0.02 to 0.2, these are all in terms of percentage, and it looks like we need 100 mils of each. So divvy this up, let your group process these samples or these standards, get them prepared, get them ready, and in the two blanks over here to the side, you're going to see volume of your ethanol that you should be using. And how does that equate to microliters? You won't need to use a micro pipetter here. I think the volumes are big enough for you to use a glass pipette for, which is why we are making you do the concentrations we are listing into the lab, so they're workable, things that you can manage with a glass pipette. But all this requires is a CV-CV dilution, right? You started off with a 1%. You want to know how much of it do you need to use in order to make a 0.02%, and you need 100 mils of it. So you do that equation all the way through for each one, using 1 as your starting concentration. Notice I did not do anything with percentage. I didn't do anything funny with it. Just treat it like molarity, treat it like part per million, treat it like part per billion, treat it like normality. Any of the units that you've got acquainted with over this course of time, you do not treat percentage any differently in the MV-MV or CV-CV equations. Once you do the math, we don't want you to just do it. We actually want you to check your calculations with us, so that way we can check off on those and we can make sure that you are doing the proper standard prep. Right? In other words, we don't want you to waste your time and go back and do it all over again, because you probably don't have time to go back and do it all over again. The next part of the procedure, we're going to make what we call a stock verification solution. Ideally, this should be made by a different team member. The reason is because one person will make the initial, and we want to make sure that that person did their job the proper way. So this is just a quality parameter that we're putting in place. And we're going to get someone else to make that same identical concentration, no difference in them. It's the same step. Look, weigh 1 gram, make sure that you correct for ethanol, 95%, put it into a 100 ml flask, dilute to the solvent, label it accordingly. All of that is the exact same. It's just made by a different person. Hopefully you did it the right way, and they did it the right way, and these numbers are the same. But if one of you all screwed up, we're going to know about it with the help of this stock calibration solution, the verification. Next is the preparation of the working verification solution. So that's like way too strong. So in this next step, what they want you to do is they want you to pipette 3 mils of that into a volumetric flask, dilute to the line with water, and then label it. This is what's going to be ran, the working pieces, not the stocks. Someone else in your group could maybe be in charge of the internal standard, because we do require an internal standard here. The internal standard, again, for those of you that have maybe taken 150 but maybe forgot about what the internal standard was, is a way that we can just double check the instrument. We are using auto samplers here. We want to make sure that needle is injecting the proper amount every time. And that's the purpose of the internal standard. So we're going to add this to everything, standards and samples and all. Everything that gets run on the machine, this piece gets added in. And it's going to be added in at the same amount every single time. And those areas or the signals that we see on those reports should all be the same. So an internal standard will be used. It tells you how to make it. You're going to weigh out 0.5 gram of N-propanol into a beaker. Prop means 3 for you organic people. Prop, 3 carbons, CH2, CH2, CH3, and then off of this is an OH group. The N means normal, so that means it's a straight chain with the OH hanging out at the end. You're going to put it into a liter volumetric flask, and then you're going to add 10 grams of sodium chloride as a stabilizer for everything. You're going to shake it up, make sure it all dissolves, go up to the line with solvent, and then label that. You're probably going to say, why on earth did we make a liter? We're only going to be using like a couple of milliliters at a time, right? Okay, so the reason that we want you to make a liter is because look at this amount. This is already a half of a gram. If we shorten this down to 500 mils, then this is going to be 0.25 grams. If we go down to 100 mils, this is going to be 0.05 grams. We don't want those small values. We want workable numbers that we feel really good about, that we can measure, transfer, and go and put it into a volumetric and dilute to a line and feel good about the final result. Small little tiny volumes in grams are not going to do that for us. So that's the preparation of the internal standard. Next, our preparation of the quality controls. There's going to be 2 of these. You're going to make them the same. One's going to be for you, and one's going to be for someone else. So these directions are basically going to tell you, pick out a QC that you would like to make. Make sure it fits within the window. So I'm going to go back up to this table of 0.02 to 0.2, and I'm just going to pick one of these. Doesn't matter. It can be one of these if it wants to be one of these, or it can be anywhere in between. You know how many milliliters that it took for all of these to take place. So just pick a milliliter that's in that range, somewhere, some form, some fashion. I don't care what it is. And you just write it down. All right, so let's say that this range goes from 2 to 20. Well, you can pick anything from 2 to 20 mils to make your quality control standard with. Again, that is up to you and that's up to your team. But you're going to make 2 of these. All right. One of the quality controls will be for you. Your team will put it into the batch of samples. You will analyze it. You know what concentration that is. And hopefully after this analysis, that concentration will be very close to what you made. But then the other QC that's identical, make them the same way. Make it easy on yourself. You're going to give that to another team. But you will not tell them what the concentration is. It's up to them to decide what that value is going to be. You need to keep it from them. Don't be cheaters. Be the quality control department that we want you to be. That's the purpose of this exercise. All right? So one QC you will analyze, you will know what it is, and you can check off to make sure your data makes sense. The other QC will be unknown because the other team will not know what you've made. They're just going to run it, and they're going to calculate the concentration. And then in the end, we will write down what that concentration was supposed to have been to see how close their data really got. So basically what that means is that you are going to have one of your own that you've made. And if you're going to give your QC to another team, that means somebody's got to give you one, right? So then you're going to have another one. And the other one is going to have an unknown concentration. This one you will know the concentration of. So 2 QCs go into your batches. One of yours and one of someone else's. Never share that concentration with another group. The only thing that we want you to do is tell us what that concentration is going to be. That way we can make sure that we write it down, and if you're not there that day, or if your lab group has left early and the other lab group's still there when they want to know how well they did, we have something to go by. We don't have to call you up, and you don't have to give us that concentration again. Next are going to be the preparation of the standards. So you're going to have a series of standards that you've made from that table up above, and it's going to tell you how to do these. Number 1, obtain a headspace vial. It's the glass vial that's going to have a cap that you're going to have to crimp. Then you're going to pipette 1.8 mils of the internal standard into the vial. So if I go back up, here's the internal standard recipe. Right there it is. So I want to make sure that I pipette that proper amount into every standard. There's my internal standard addition. Then I'm going to add 0.2 mils of the calibration standards that I've made from that table. So I'm going to have 5, 6 different vials in each one. So let me just draw that over here to the side just to clear up any confusion that might be going on. But here are my working standards. Let's say that these came from the table, right? You're going to pipette 2 mils of the standard of my 0.02, and then 0.2 of my 0.04, and 0.2 of my maybe 0.08, and 0.2 of my 0.1 maybe, and 0.2 of my 0.2 percentage. So different standards go into different of the headspace files. Then in addition to that, what will now happen is that I will take the internal standard, and this will be 1.8 mils, and I will put the same amount into each one of these. That internal standard will therefore stay constant, and that should show up on my data sheet that way. We're going to crimp the vial. We want to make sure that we have a very good crimp on the vials before we run them. If not, we are not going to get pressurized systems, and they won't transfer over. Then you're going to do that with your QC samples as well. You're going to take additional vials. You've got one for you and one for the other QC that you've obtained. You're going to put 0.2 mils of the QC here, 0.2 mils of the other QC there, and then you put 1.8 mils of the internal standard into each one of those. And then finally, you're going to repeat it for the working verification solution. So you're going to take another vial, you're going to put 0.2 mils of the working verification into that vial, and then you're going to put the 1.2 or however many mils of the internal standard it was that goes into that one as well. So you're going to have a total of 9 standards that are going to be prepared the same exact way. All right? There's going to be no difference in those. 9 of them. A group of them will be used to make a calibration curve. The other QC samples are going to be used to make sure the calibration curve makes sense. And the working verification solution is going to be used to make sure that the person who did the calibration original actually did it the proper way. So these are quality control parameters everywhere within the sample prep. Next are the preparation of the samples that you're going to analyze. And there's no surprise here, but those are going to be done in the same exact way. You're going to have a series of samples, let's say 3 of them. You're going to pipette 0.2 mils of sample into each one of the headspace vials. And then you're going to pipette 1.8 mils of the internal standard into each one of them. Again, the internal standard is staying the same in every single run all the way through. You put the lid on those, you crimp them, and then you'll bring the whole set over to the instrument. But before you do that, read the last sentence. For each sample, you're going to create a laboratory duplicate. So if you have 3 samples that are different, you're going to do each one of them twice, and you will add a total of 6 into the calibration set, and that is what you'll analyze on the instrument. If you have 5 samples that you have to analyze, you duplicate them all. That will be 10. And you add those 10 with all of the other calibration standards from above, and you will run that as an entire set. So that's the preparation of the samples. They will be real blood. Make sure that you wear gloves and treat everything accordingly. And this is the preparation of the standards. A lot of things going on here. And that is one of the reasons that we wanted you to work in a group and not by yourself. Share the responsibility. Make sure that you do the entire set in completion. But that way you can only focus on bits and pieces of the sample process, because we really need to be focused here about the instrumentation and the way the instrument's doing its job, not how can you prepare standards and samples the proper way. That was the purpose of the 150 class. That's not the purpose of the 210 class, okay? Next, at the end of the lab document, you're going to see the data sheet and the lab questions kind of mixed in together. It's going to want you to print off your chromatograms. It's going to want you to attach those. It's going to ask about areas and retention times and things that you've seen. It's going to want you to do a calibration curve. If you've not taken the 150 class, you need to get with someone else, with maybe your group, or you need to get with one of us or myself, and we will show you how to generate this calibration curve the proper way. We know what the target values are supposed to be. So we're going to take a look at these target values to see if you're in an acceptable range. If not, then that means you made everything wrong, and we're not going to give you any credit for that. You should know better than making standards and samples the wrong way. Did you plot your calibration curve the proper way? Did you process the samples the proper way? Did it fall within an acceptable window, because we know what the QC samples are supposed to be? Did your verification fall within a window? And then the samples fall within the window. They are blood samples, but we know what should be there with the blood sample. We know what those values should be. They are not unknowns to us. They're unknowns to you. So you are running these like you do not know what's there, because you really don't, and you're going to solve for what's there in those blood samples, but we know what is present. So we have an acceptable window that we will be looking at for our sample preparation. All right, guys, so that's it of the blood alcohol content lab. There's a lot of things that are going on. There's a lot of new bits and pieces. We got a complicated piece of machine. We have all of these standards from quality control purposes that are going to be involved in this process. And these samples are going to be loaded up on one day, and you will not get your data for that day. This will be a process for the machine to analyze. I think each one of them takes about 15 minutes in total, not including a total cool down and heating up ramp that goes along with each one. So this is going to be an overnight run, and the next day we'll have data, and then we'll send that data to you, so that way you can process that data on your own and have this information ready to be turned in on the next lab period. All right, so a lot of stuff going on, but good luck on the pre-lab questions. I'm going to ask about different processes and different things that you need to take away from this blood alcohol content. So review some of the terms about the equipment. I want you to review what BAC actually is. What kind of molecule are we looking for? We need to look at, in the diagram or the picture here of the GC instrument, some of the pieces and parts that we've talked about throughout this lecture. Can you explain those on your own? Can you explain that to someone else maybe who has never done it so far? If you can, then I think that you'll feel pretty good on the pre-lab questions. And then finally, this idea of headspace. What is headspace? Why is it important? What does the headspace do? And what happens when the needle punctures down into the septa? Where does the sample go? So those are the things that we're going to be focused on in the pre-lab questions. So good luck. Study good. You'll have a limited amount of time to answer those questions before time expires and it counts everything wrong. So if you've got any questions, you know how to reach me. Email or phone.